Hi, and welcome back. I hope you had a great lunch. My name's Wim. I'm your track host for the automation track, and I'm proud to present you Scott McAllister, who is a developer advocate for PagerDuty. Sorry, not PaperDuty. He's going to talk a little bit on build testing in with Go. It's a tool or a library. I don't really understand what it is, but I'm very curious to hear more about it because it's something new for me. I also have to tell you it's a pre-recorded session because Scott couldn't make it. He's a last-minute replacement for somebody that fell ill. But you can still participate for the award for being the most active participant. So if you want to win some free ebooks, do not forget to rate this session as well and to leave any interesting comments that you would like to share with the rest of the group. Enjoy Scott's session. There won't be any Q&A for this session, but at the end, I will come back to guide you to the next session.
Hello, TestCon Europe. I'm Scott McAllister. I'm a developer advocate at PagerDuty, and I'm here today to talk about testing in Go. Go is a programming language created by Google, and what I want to do is take you on a journey, my journey, in fact, where I learned about testing in Go and how to properly do it, but also share some of the learnings that I've discovered along the way. And like every journey, it always starts with a good story. So for me, a couple of years ago, I joined PagerDuty as a developer advocate. And like everyone else, when you start a new job, I was super eager to impress. I wanted to really make an impact when I joined the company and wanted to make my presence felt and make it, make my mark, right? Everybody wants to do that. Everybody wants to come in and to look good when they start a new job. And I was talking with one of the other developer advocates, and we were sitting there and talking about various projects that were going on, initiatives that were happening. And, being a developer advocate, I was focused on, the API and the developer experience using PagerDuty. So I asked about SDKs and API client libraries. And the other advocate said, oh yeah, we have this great project, this great client library called Go PagerDuty. And it's awesome. It's really popular. A lot of people are using it. However, it's really slow at reviewing pull requests because there's no testing in it. Every time a new pull request is opened, we have to go in and manually test everything and make sure that it's not going to have any adverse effects. So I wrote that down in my little notebook that I had, right? Yeah, everybody's scribbling down notes when they start a job, and made a mental note of, okay, that's definitely something that I could do to make an impact. And I started learning about lots of other things, and I ramped up on this job. And like it happens most of the time, a lot of our priorities that we think we have right at first slip, and other things become more important. And so working on this Go library fell down the priority stack a little bit. What did pop into my priority stack was something called the Terraform, or the PagerDuty Terraform provider. And in case you didn't know, Terraform and its providers are written with the Go programming language. And so I jumped into that project because I saw the value that it would provide to our customers and our users. And I learned Go. I never knew the programming language of Go. So I learned that. I learned a lot of the different features and ideas that people use when programming in Go. And what I loved about it is I was able to jump in on a project that was already in motion, already active, already having various standards that were set. And one of those standards was testing. And so I saw that testing and how we did testing in that Terraform provider, and realized, okay, when I start out testing, or when I implement testing in this Go PagerDuty library, when I can get back to it, I'm going to use these ideas from the Terraform provider. And I, as is the case, around the holidays, right around in December of that first year that I was at PagerDuty, there was a little bit more time. And so I was able to, put my head down and get some tests put into the Go PagerDuty library. And I was so excited about it. I was taking all this new knowledge I learned from the Terraform provider, putting it into this Go PagerDuty library. And I loved it. It was great. I had this, I put tests in for each of the endpoints on our API, every single one of the methods on the API, or each one of those endpoints. So there was a lot of tests in there. But I thought, well, go big or go home. You want to be able to, you don't want to test half of a library. You want to test the whole library. And so I put all that in, created the pull request, and started looking for someone inside the company who would be willing to review that pull request. And before I could find that person, which wasn't very long, right? I mean, the community that surrounds this library is super active. And so before I could actually connect to another coworker, someone inside the community gave some comments or some feedback on what I'd done. And in the moment, I was like, oh, hey, I thought this was a great pull request, and I thought it would just slide right through, and just people think it was so wonderful, and they'd give a stamp of approval, and we merge this thing, and it would be into the library before we know it. But a member of the community gave me 2 pieces of feedback that stick with me to this day, and they're good pieces of feedback. This person is super active in the Go community, very knowledgeable, really, really helpful, and so I appreciated his feedback. The first thing he said was about the size of the pull request. Now, that's outside of the scope of this talk, but the idea that he gave me still sticks with me today. He was a little frustrated that I created such a big pull request. I've since thought about this, and as I've managed other open source libraries. Yeah, when you make pull requests, you probably should start small, especially when you're implementing a new idea like testing. Start small with a couple of tests, get people's stamp of approval on that, and then increase from there. In this case, he was frustrated because he didn't have the time to go through each one of my tests to see if they all looked good. But of course I said, of course it's good, right? I wrote this. But no, that was good feedback to have. The next thing, though, surprised me. He wanted me to basically use the built-in libraries as much as possible. And here I was thinking, but we're implementing testing. From my coding background before working in Go, I mean, you use external libraries for testing. I mean, if you're in JavaScript, you're going to be using Jest or Mocha. If you're in Java, you're going to be using JUnit or JBehave. Python will have PyTest or Robot. All of these languages have testing, but you really want to be implementing an external library to run this testing or to write these tests and to manage and implement them. And at this point, I do want to say there are definitely external libraries in Go that can provide assistance with tests, but we're not going to talk about those today. It's outside of the scope of this talk. Today, we're going to talk about the built-in libraries that we want to be using. Because Go, when it was created, the point of Go was to make developer lives much more productive and easier and effective. And so that was one of the promises that Google gave. Google created Go back in 2009. And so it was designed to solve Google's problems where they needed things to be able to run efficiently, run very fast, but also to develop things very quickly. It had a lot of great characteristics, such as being open source, being statically typed, powerful standard library. But then with that powerful standard library, it also provided built-in testing. To get everyone on the same page, now this being TestCon, I'm sure many of you already have an idea of what testing is, but I want everyone to kind of have an idea of being on the same page. Let's all be on the same level. Let's level set. So testing in software development is to evaluate and verify what your code does. Make sure that when you put an input into a certain function or into a certain area of your code, the expected output should happen. It should behave as you expect. And that's what you're verifying and evaluating when you're writing tests. When you write tests, another point of that is that you need to actually write testable code. I was sharing this idea of this talk with a coworker of mine at PagerDuty, and I told him about how, we should talk about testing a little bit just to level set with everybody. And he smiles and laughs a little bit. And he says, when I learned about testing, especially when I was testing in Go, the first thing I realized is I needed to rewrite a lot of my application code to make it more testable. You want to make sure that your application code is separated out into single responsibilities, that it's decoupled from one another so that you can have pieces of your code that you can test, that you can isolate those pieces of code, but then also bring them together. So if you take lots of your pieces of code and then you're wrapping everything in a big function that's basically saying everything goes through this one big function, that's really hard to test. So make sure that when you're implementing testing, that your application code is also testable, that it's something that's decoupled, has single responsibility throughout. And then Adler gave this great quote on the internet recently, talking about how good tests honestly act as documentation. It encourages clear design. Goes back to that same idea that my coworker had where he said, write testable code, keep things single responsibility, because that last bolded point, this will boost your productivity. Not only your productivity in building code and writing code, but when you look at software applications, when you look at software development, we're actually spending more time reading our code than actually writing it. So you want to write readable code, not only testable code, but readable code, so that you can understand what's going on quickly and make changes. That's the whole point of all this, right? If you write readable code, it makes it so you can fix bugs and add features a lot easier. Same with tests. It has the same point there. We're trying to write code that we know will act as we expect so that we can add features quickly and debug quickly. Because we're looking at that code and we want to make changes, additions, or some updates there. Let's talk about a couple of different types of testing. First, there's unit testing. And that's when you're taking those little bits that we talked about, how you're trying to separate out all the responsibilities into single responsibility. And you're going to be testing each one of those units. You're breaking down the code into the smallest possible logical unit, essentially, that can be isolated. And by isolated, I mean like really isolated. If a function is reaching out to a database or to another API, like in our API client library, you're actually going to want to mock that. You don't want to actually reach out to that API because you're not testing whether that API works. You're not testing to see if the database works. You're testing to see if that little bit of code that's interfacing with the API works. So make sure that when you're writing your unit tests, they're really encapsulated and really isolated so that you can really make sure that that one feature works as expected. But then once you verify that the little units work as expected, you want to be able to take those units and string them together, to integrate them together into more real-world scenarios. And so that's what we call integration testing. It's when we take all of our units and we start combining them together and into something that's really what's happening in our application. And so with integration testing, that gets real. That might actually reach out and hit an API or hit a real database. But you want to make sure that not only does your code work isolated, but that it works together as well. So now that we talked about testing a little bit, let's talk about how we implement testing in Go using the built-in libraries. Now, the first thing that I learned is that testing in Go first requires naming a file with _test. Now, if you look at this here, this list we have on the screen, this is the actual file structure of our SDK. And you'll notice that the test files are living right next to the application files. We have the ability _test file right next to the ability file. This is the most common way that I've seen things done. And I've seen different schools of thought on this idea, where you can either keep all of your test code in with your application code so that it's easy to see that here's my application code. Now here are my tests. And this is what I've seen most. I've also heard of folks separating out their test codes so that it's in its own directory and calling the application code. And the argument there is because your tests are now running a little bit more realistically as a client. And so you could think of it that way as well. However, I've typically seen it more with the files together in the same directory. But the key there is to let Go know that the file is a test file. You want to have the functionality in the name and then underscore test.go. This will tell Go when you're compiling an application, compiling your code into an application, that don't compile this particular file. This is only a test file. Don't compile it when you're making the application. But also when you're running test commands, these are the files that you're going to be running, not the application code per se. You'll be introducing the application code through those underscore test files. So digging into those test files, each of those test files will have test functions. Test functions need to start with a capital T test and then the name of whatever function that they're testing. In this case, hello empty is more just for demonstration purposes, but if we're going to have something that is really effective, we'd probably say, that it's going to be user add or something like that. And then another piece that's required is this argument they're going to be passing into that test function. We have a testing.t object that we're passing the pointer of that object into this function. This is a utility function that allows for working with various testing functionalities or testing abilities. And the idea with testing.t is it can call things like run or fail or skip and a various variety of other functions. And the one I want you to keep in mind for later on in our conversation that we're having today is that run function. It doesn't quite do what you initially might think. However, skip, fail, error, fatal, things like that, those are things you'll be using all the time. And so you have to pass this into the function to let Go know that, yes, this is a test and here's access to these different abilities inside of the testing.t object. Now, a test, what it has. Let's talk about the key requirements of a test, or I almost want to say it's the anatomy of a test. So inside this test function, we have a test add function. And so we're going to have an input that we're going to have in our test. And we know with that input, we're going to have an expected output. So with that expected output, I know if I pass in a 111, in this case, my expected output is going to be a 333. Then I'm going to need to actually run the function. So I'm going to call do magic and then see what I get. And then I'm going to take what I get and compare it to what I expect it to be. And then we decide what to do from there. In this case, if they're different, then our test should fail or error. And then we should pass out a message that's probably a little bit more descriptive than what we have here on the slide. But this gives you a general idea of every test should have an input, an expected output, get the actual output by calling whatever function you're testing, and then assert that the expected and the got are the same. And then you just run go test. That easy. Now, let's jump out of the slides here and jump into some code, because code is more fun to watch. So I'm going to pull these slides away and come into some code here. And here I have a really basic idea for a calculator. And in that calculator, we have some very basic functions for adding here. And what I'm going to do is I'm going to increase the size one tick here for us so we can actually see what's going on. And inside this calculator, we're starting out really, really, really basic. We want to have an MVP just to see two different arguments come in. I'm going to see either add, subtract, multiply, or divide these two things. And then I want to return that the result of those things. We also have a main.go file, which is essentially all of our CLI commands, but we're not worried about that right now. What we're worried about is writing tests for this math object that we have. And so inside math, I'm going to have also a math_test file, because that's how we learned, right? Is how we write our tests. And so what I'm going to do is I'm going to show some tests on this math file. And after talking about that, we're going to talk about how the tests work in this simplified environment. And then we'll even dive in to the API client library that we have and show you how we're doing it today in production with real live production code. So I'm going to go over to my math.test or math_test file. And I'm going to look at this test I have here. And in this test, I have my first and I have my second, because the add function requires 2 arguments. I'm going to take those 2 arguments and get it whatever I got. I'm going to take my want, and this is my expected value, and I'm going to compare them here in my test. This is essentially what I'm looking for. And then I'll call a fatal if it doesn't. That'll fail the test. It'll kill the test just for that one, for this particular function. And I give it a little bit better of a descriptive here. Rather than just saying kaboom, we're going to say, you know what? This particular test failed. Here's argument number 1, argument number 2. Here's what it should have been. Here's what it was. By having all of these, we can understand now that, okay, that test right there is wrong. And I can even look in that object there and say, okay, that's why that's wrong. In this case, let's run this test just to see how it goes. I'll pop out here to my terminal. And I'll say, go test. And it failed straight off the bat. So math test 1 failed. 111 plus 222 should have been 3332, but was 333. Okay. Let's look at this here. We'll come back here. Looks like we had a little bit problem in our logic. So the good thing about this idea, or running into this error first off, is we look at this and say, oh, this message is providing a good indicator that is my code wrong or is my test wrong? If I'm looking at this and I say 111 plus 222 should be 333 or 332, a lot of threes, but it was 333. I look at this and say, actually 111 plus 222 should be 333. So the test is actually wrong. So I can see that my test is wrong, but I also can see that my assertion that I'm doing, the part where I'm comparing the got with the want, that's actually working correctly. There's a message. So this is good. It's a positive failure. We come back here and I say, all right, let's fix my test. I'm going to come into here and make this correct. And then now I'll run the test again. And it tells me it passes, and that's good. However, if I write more tests, this is all that it will tell me. It just keeps telling me, yep, everything passed. Everything's good. That's good, but not very helpful. So there's one flag that I recommend that you call all the time, and that's go test -v. -v is for verbose. It gives you messages of each of the tests that we're running, tells you that the test ran, that the test passed, even tells you how fast it was. This one is pretty small, so it took less than any time at all. According to this message, it was no time at all. That's great. So we have a test function for add. But like every other good testing ideas that you are implementing in your code, you want to be testing not just a single path into a function. You want to test multiple paths using that function. You want to test interesting ideas that your users of your code are going to be, you want to possibly be thinking of any scenario that they would be using so that you can really see and really test whether that code is solid. So I'm going to come in here and I'm going to have another test for adding. And let's pass in some negative numbers, right? So let's do a negative. So I'm going to pass in a 245, a negative 300, and then it's probably going to be a negative 55, right? Negative 300, 240. Yeah, I think it's negative 55. I trust myself and my previous typing abilities. And then I come in here and I have the same code going on. So same code for first, second, and want. except for these values changed. And then when I go into the got and the assertion, that's all the same code that we had before. Feels a little redundant, doesn't it? A little bit. So that's fine, but let's just keep that there and let's run this. My dash V and my tests pass, my code works. This is awesome. Now I can add even more and more tests going on, and that's great. A lot of code though, right? I mean, that's a lot of code for running 2 tests that do essentially the same thing. I mean, that's line 7 to 30. That's like 25 lines of code, 23 lines of code if you're getting picky. And that's to do the same thing, but with just different values. Keep that frustration in mind, but pack it in the back of your mind for a second. What I want to do next is now we want to call an integration test. An integration test, remember, is when we take an individual unit. So in this case, a function like our add, subtract, or multiply functions, and then we're going to string a bunch together. So in this case, I'm going to take my test integration here, and I'm going to have a first and a second, just like we had up above. And then I have my want. So I'm going to say, in this case, we're going to multiply a couple of function calls. So I'm going to take add and I'm going to take subtract. So add's going to take 100, add it to 200, and then it's going to multiply it when you take 200 and subtract 100. 200 minus 100, that's 100. And then adding 200 plus 100, that's 300. So 300 times 100 sounds like it should be about 30,000. And so that's what we have here. Should be blank, got blank. Could take my integration test. And that's happy. Great. So we were able to do our math really quick there. So thinking back to the idea that I was kind of driving home right before running my integration test is how we had 23 lines of code doing essentially the same thing over and over for the same test, but we're using different input values. Go actually has some functionality built in that lets you address this issue. And that's made possible through something called subtests. Now, subtests is the idea of being able to run a test inside of a test. Okay. Just like those Russian dolls on the slide, when you have those dolls that are like a doll inside of a doll inside of a doll, you can write tests inside of tests inside of tests to group them together, but also make it possible to be a lot more efficient with the way that you're writing tests because you're using a concept called table-driven testing. Now, looking at this code here, we have this idea where you can take a list of structs. Now, a struct in Go is essentially a key value pair object where you have an object that has some defined fields. Those are those keys that you have, and then each of those keys has a value. In this case, that first object in the struct, we're able to define the fields. So we have an input and we have an expected. Both of those are float 64 numbers. And so the next struct or the next object that you see there in the curly brackets, you see a list of 2 values, right? Which is one is inputted, the other is expected. And for each one of those, they represent a test. So you have a test. If you pass 1 in, you'll get a 3. If you pass 4 in, you'll get a 9, and so on and so forth down the list. Making your code testing, your code writing, your test writing, I should say, a lot more efficient. With that list, then we just loop over that group of inputs and expected values. So in this case, this is the Go code that loops over that code or loops over those tests, over that list. It creates a name by using the input value that we have. And then we use t.run, which is, again, one of those utility functions off of the testing.t object. T.run helps you run or make subtests possible. A t.run is a subtest. And so with t.run, you pass in that name. It has a callback function, which is the function of the test, which looks really familiar to the previous tests we were writing. This one now calls that add function. It uses the input value. It gets a got, right? Or the expected value, and then compares it. It compares the expected value with the value that it was not expected, but the actual value. Here's our table of tests, all written, all ready to go. And then here's our loop. I'm going to take my list of tests. I'm going to range over it or loop over it essentially, where I get an object of a test. We'll call it TT. With that TT, we'll get the first and the input values and create a name, because each test needs a name. When it starts listing lots of tests inside of a subtest, right? Or lots of subtests inside of an outer test, those tests need a name. You need to be able to identify what's happening, what's going on. And so that's how we built our name here. We're just going to take those first two values, first and second, and we'll just add those together and make a nice name out of that. Use t.run with my test name. My callback function first calls that add function right here. I compare my got with my want, or my tt.want. I give a detailed message in case it fails. And then we'll close off that loop. Make sure we have enough closing brackets here. And here we have about 20-ish, 19 lines of code, but now we're testing our function 5 different ways. So a little bit less code, and we're doing 5 tests. Let's run this and see how the output looks. That was quick. So we give our test here, and here we have, this is what we saw before, our run, pass, run, pass. Then we hit this whole section of subtests where it sits and it runs test all, but then it runs test all and it gives you the slash and then the name of those tests. The results are then outputted in an indented way. They're given here. The passes are all put in indents. Those indents will tell you that if you're just looking at these tests and you didn't see how they were written, I would know that if I see indents like this, these are subtests. These are inside of another test and they're being run through a t.run. That's nice. It's be able, that way you can be able to look for the tests a lot easier when you're reading through that test code. In our case, all those tests pass, and that was great. To not make the integration test feel left out, we can also run that integration test as a subtest inside of our test here. So we're testing everything. We can say test integration. We'll run t.run. We give it a callback function just like we gave above, where we have this function of calling multiply, which passes in an add and a subtract. It gives us a product, or a, is that, yeah, product. No. What's the thing when you call a multiplier? I forgot. But it gives you a number when you multiply those two numbers together. And here we go. Our integration test runs and it also passes. So hopefully that gives you at least an introductory idea of how these tests run, how you would write those in Go, and how the different pieces you would want to use. If you want, I'll give you a link at the end of the talk for this code specifically that you can go in and try out these different simplified ideas and play around with them, mess around with the ideas that are there, so you can see how they would work in your line of work. But what I want to do next is show you how we're actually implementing it today inside of our Go library. So I'm going to go past our demo code here. And in our Go library, the first thing I want to show you is the usage of our table-driven testing. We have a particular spot where we're testing out how we process some JSON errors that we receive back from the API. We'll receive a certain error from the API in JSON, and we want to be sure that when this particular JSON input comes through, that the value that we're producing is something a little more better to read in this case. And so we have a want value that's tied to each one of these input values. Our struct has 3 strings: name, input, want. We give it a name. We give it an input, we give it a want. This is what we want. And then it's going to loop over each one of those tests, passing in those ideas and checking to make sure that these are what we output there. And then also, there's another one here with the test get base prefix, just testing out various URLs, right? Making sure that when we get one type of prefix or one type of domain and then rest of the URL, that the output is the same or what we expect when you run the get base prefix function. So that's what table-driven testing looks like in our API client library. What I want to do now is to show you what we're doing with our unit testing. So with this, remember how I talked about how unit tests should be completely isolated, which means that they shouldn't be reaching out to APIs. They shouldn't be reaching out to external systems or databases or anything like that. And so in this case, we're not reaching out to the API, but an API client library has to understand how to handle a response from an API, because that's what's happening. I'm calling this function, it's going to get a response from an API. So rather than reaching out to the API, we are going to mock that API. The reason why we're doing this is because we're not testing the API. We're not testing whether the PagerDuty API in this case is behaving properly. We're testing whether our code is behaving properly based on the response we're expecting back from the API. So in our case right here, this one is going to test an object we call a business service at PagerDuty. And the functionality of that test is we're creating the create method. And so, or the action on the business service. And I have my create here, and it's calling this handle function. The handle function actually stems from a mux object that's created. We create that mux object here in this setup function that's tied back to our client test. But what it does, it essentially spins up an HTTP server just temporarily. Spins up that server, gives it a function, gives it an endpoint of business service, and then you write in what you expect that output to be. So when you're writing that test, you look at the API, the actual API in production. I look at business service and say, okay, the business service object is going to have an ID, it's going to have a name. And those are the two fields I'm going to be testing in this case. And then I'm going to be able to set up a default test client. And then I'm going to take my input where I want to create a new business service. And so the function is looking for a business service with the name of foo. I pass that into the create business service function, testing out that function inside of the API client library. I get the response. And then what I expect is that I'm going to have an ID and I'm going to have a name. The reason why I expect that is because I've defined it up here in the JSON. So what I'm testing is I'm making sure that with the JSON that is being passed in, or with the object that's being passed in, that JSON is going to be processed and essentially what we call marshaled in the Go programming language to make it into the right Go objects. So I want to make sure it turns it into a business service object. We're going to create a pointer for that, or to that object. And I'm going to use or set these values of ID and name. So essentially what I'm saying here is the fact that this is what we want, because this is the Go representation of this JSON that we have here. That's what our API client library should be doing when we when we run this function. And in this case, if there's an error, we'll have a fatal and we'll say, hey, this test failed. Otherwise, we're going to test to make sure that it's equal. That test equal is an internal function that we have up here, where it essentially just tests those two values and makes sure that they're equal. This particular function is an example of what's called a helper. That's another utility function off the t.testing object. That helper allows you to write helper functions inside of Go so that you can have these helper functions that don't get outputted when you're running the tests or anything like that. No line numbers or anything are outputted from those helper functions, but they're there to basically say, hey, this function needs to run and help with the test, but you're not actually testing anything in here. So that's something that another example there. So that's how we use it in real life. In real life, in our Go PagerDuty SDK, you see how we have tests and how we were able to implement those for our users and honestly for our developers who are working with the API client library. If you're interested in looking at that code or the demo code that I was going through with the math functions on there, you can find the Go test demos. That's the math stuff, the little calculator app that I was building. You can find that on my GitHub at ST McAllister and the Go test demos. If you're interested to see how we implemented it at PagerDuty, go look at our API client library. We have a link there that allows you to go look at that library and just see how we're implementing it. And you can kind of see how we're doing it in production in real life. I want to thank you all for listening to my talk today. And as I mentioned, I'm Scott McAllister. I'm a developer advocate here at PagerDuty. And as we like to say here at PagerDuty, I'd like to wish all of you an uneventful rest of your day.